Good morning. Okay, we are going to start reviewing really in earnest for the AP test now, right? So you've had some taste of it the last 2 weeks. Now we're really going to step up our game and start to review some free response problems. So hopefully as you do these practice tests, you're kind of categorizing these problems in your mind. Now today we're going to focus on these types of problems, these particle moving along a line problems, speeding up, slowing down, those types of problems. The other types of problems you've been encountering, right, are differential equations with the slope field problem, maybe the rate problems, maybe interpreting the graph of f primes, kind of putting these in categories, right? So today, okay, so we're going to focus on this one from the 2016 actual test. This was interesting because you guys had it last week. So now I'm going to do it for you, and you'll say, "Oh, well, that was easy." Hopefully, that's what you'll say anyway. Okay, so here we go. For t is greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by this. Okay, the particle is at the position x equals 2 at time t equals 4. Okay, so they're giving us some initial condition there. Okay, and then part A, at time t equals 4, what is the is the particle speeding up or slowing down? Okay, so go back to your flashcards. Speeding up and slowing down, what do we need to know? Exactly, you're exactly right. We need to know velocity, the sign of velocity, and the sign of, you got it, acceleration. So we're going to say, okay, our velocity is this, and we're going to plug that into our calculator as y1. So that's going to be my y1 in my calculator. And now I'm going to take the derivative. I'm going to find v prime, which is a of t, right? Can you see that? Yeah, okay, good. All right, derivative of 1, that goes away. My 2 goes along for the ride. Take the derivative of sine, I get cosine. Keep the inside, and then the derivative of the inside is 2t over 2. And those go away. All right, so now we've got a of t is equal to 2t cosine t squared over 2, if I did that correctly. And that's going to be my y2. And then I can just look and see for speeding up and slowing down. Now, if I wanted, let's go ahead and put them into our calculator here. So I'm going to clear out my calculator. 1 plus 2 sine alpha, put in the fraction here, x squared over 2. And then close parenthesis, and then the next one, y2, we'll do 2x cosine x squared 2. Oh shoot, I didn't put the fraction in. Oh well. We'll do alpha. Oh, now I really messed it up, didn't I? Okay, alpha. There we go. It's hard to teach an old dog new tricks, isn't it? Okay, there we go. Okay, and now we could graph this if we wanted to, and see what it looks like. Let me make sure I'm in the right mode. I am not. I am in degrees. So make sure you're in radians, and then go ahead and graph it. So, oh my goodness, look at that. So if they asked us, what are we slowing, or the intervals of slowing down, speeding up? We could look at this graph and find those intersections, but oh my gosh, that would be a lot of work, right? So obviously why they asked us this particular question, we don't need to be able to interpret this graph. We can just go to the table. So we're going to do second function table, and I'm going to put in, you're right, 4, and find out. So at 4, we have a positive velocity but a negative acceleration, which means we are, that's right, you got it, slowing. So I'm going to say v of 4 is equal to 2.9787, and a of 4 is negative 1.164. Negative 1.164. So we can say the particle, and you've got to answer the question on these. They're particular about the grading. The particle is slowing down because v of 4 is greater than 0, a of 4 is less than 0. And we're good. Okay, now we're going to do part B. Part B is, can you guys still see that? Good. Find all the times t on the interval from 0 to 3 when the particle changes direction. Justify your answer. Okay, so now I'm going to go back to my graph, and I'm going to change the window from 0 to 3. And to change direction, that means if we're a positive velocity, we're going to the right, you got it. And if we have a negative velocity, we're going to the left. So all we have to do is figure out, okay, when is it changing from positive to negative? And I am going to plot that, graph that, so we can see where it's graphing, and right there, it looks like it's changing direction, right? And then this is the acceleration, so we don't want to look at that. And in fact, if that's confusing us, we can go ahead and clear it. We might have to put it back in again, but it's better to be safe than sorry. So yeah, so I want to find that spot right there where we're going right, and then we stop and we start to go left. So let's go ahead and put in a 0 here, and then we can just do a quick graph intersect. So second calc 5 intersect, and the first curve, the second curve, yes, and we want to guess, yes, and it's jumping to that spot, which is x equals 2.7074. Let's just truncate it there. Okay, so we can say find all the times in the interval when the particle changes direction, and then we have to justify our answer. So the particle changes direction at t, remember this is time, t.7074. And we don't have units here, so it's a little bit strange. Because, and our justification is because velocity v of t changes sign. Okay. All right, find the position of the particle at time t equals 0. So if we're given velocity and we want to find position, we have to go backwards, right? Instead of deriving to get acceleration, we're going to, you said it, anti-derive. Okay, and remember, we anti-derive from what we know to what we want to know. Remember, we know t equals 4. So we can anti-derive. We can go from 0 to 4 or 4 to 0. It doesn't matter. Probably you guys would prefer going 0 to 4 because that makes more sense. So we can do that. Okay, so from time 0 to 4 of v of t, dt is equal to, right? When we antiderive, oh, I need another pen. Where's my other pen? We need a pink pen. Can you guys see that? Yeah. So from here to here, we antiderive. We antiderive v, we get position x, right? So x, and we plug in the top minus the bottom. Okay, and we know this portion, they told us back here, x equals 2 at t equals 4. So we could plug in 2. And then this one, we're going to do on the calculator. Okay, so we just plug this in. And I already have v of t in my calculator. Remember, it is y1, right? So I can quit out of here. And I can say, remember, the integral is math 9. So I'm going to show you this, math 9, and we get, oops, oh, for goodness sakes, Owen, quit. Okay, here we go. We're back up here, math 9, we did it. Now we have to plug it in, okay, and we're going to go, we already decided 0 to 4. Okay, and then we've got v of t, which is it's alpha f4, and that's going to give you the list of y1s. So y1, and then our variable is always x in the calculator. And it's calculated, and we got it, 5.815. So this is 5.8150. This is 2, and we want we're solving for this. So I'm going to add this over. So x of 0 is equal to 2, and then I'm going to subtract the 5.815. Okay, so this is 2 minus this, and that's going to give us a negative. So I get x of 0 is negative 3.8150. And you guys probably can't see that. There we go. There it is. Okay, and the last part, part D, find the total distance the particle travels from 0 to 3. So remember, total distance, we don't care if we're going right or left. Remember, we stop at 2.7 and start going left. But on the calculator, it's a nice, easy calculation, total distance. So remember, total distance is the integral from 0 to 3, absolute value. Oops, absolute value. And we plug that into the calculator, which is so nice. So again, math 9, 0 to 3, and we don't even have to type that in. We're going to do alpha f4 again. Oops, we have to do absolute value first. I messed up. Okay, so absolute value is alpha f2, and that's the first one, and then alpha f4. Gotta get my calculator groove back on here. Okay, and then enter that, and that will give us the correct answer. It will also, you could also go from 0 to 2.707, right? Mm-hmm. And then from 2.707 to 3, and then take the absolute value of the portion that's going left. But we don't have to do that because we've got a calculator that does it all for us. And that's it. You did it. You did number 2 out of the 2016 free response. Good work.